The next question is x into x minus 1 into dy by dx minus y is equal to x square into x minus 1 whole square, then 4 into y at 2 minus y at minus 1. Its value is supposed to be obtained. Okay, one can easily trace or one can easily get the idea of obtaining this into the form linear in y. Why? Because x is not linear. X square into x square, x power 4 is able to be seen here, but y lies at it only one place with first degree, hence it is surely linear in y. From this we have dy by dx minus 1 by x into x minus 1 into y is equal to x into x minus 1. I think you can easily understand what is done by me. I have divided the entire equation with x into x minus 1. Very nice. This looks like dy by dx plus py is equal to q. This is p and that is q. Let us not waste time. Immediately we can apply the first step, that is of finding if. What is integrating factor? E power integral p dx minus 1 by x into x minus 1 dx. Isn't it? Is equal to, by partial fractions it can be written as 1 by x minus 1 by x minus 1. You can easily follow it. X minus 1 minus x is minus 1 by x into x minus 1, isn't it? And now its answer is e power. For 1 by x it is log x. For 1 by x minus 1 it is log x minus 1. Therefore it is e power log of x by x minus 1, which is nothing but x by x minus 1. We could have got the if as x by x minus 1. The first step has been completed successfully. What is the next step? The last step, of course, obtaining the solution. Therefore, the solution is, you please recollect the formula for the solution. What is that? Solution is, come on, y into integrating factor, that is y into x by x minus 1 is equal to q into, what is q? This is q, x into x minus 1 into x by x minus 1 dx. Luckily this x minus 1 will be cancelled, leaving you x into x is x square. That's all. Therefore the solution is xy by x minus 1 is equal to x into x, x square. Its integral is x cube by 3 plus c. Stop there. What is needed actually? Is it enough to have the general solution itself? No, not needed, not enough. We are to find y at 2 and y at minus 1 also. After finding them, substitute in the given question, the requirement of the given question. Okay, right. X is equal to 2 implies, what does it imply? 2y by 2 minus 1 is equal to 2 cube 8 by 3 plus c. From this, y is equal to 8 by 3 by 2 is 4 by 3 plus c by 2. Therefore, y at 2 is 4 by 3 plus c by 2. Okay, 4 by 3 plus c by 2. And then y at minus 1, if x is equal to minus 1, what happens? Minus 1 into y, minus 1 minus 2, minus 1 cube, minus 1 by 3 plus c. Therefore y at minus 1 is equal to minus 2 by 3 plus 2c. Now the last and final step is remained. You are supposed to make use of these two in this question. What is the requirement? This is equal to 4 into, what is y at 2? 4 by 3 plus c by 2. What is y at minus 1? Minus 2 by 3 plus 2c. 4 into c by 2 is 2c. 2c and 2c can be cancelled, leaving you this is 16 by 3, this is 2 by 3, altogether 18 by 3. 18 by 3 is just nothing but 6. So what is 4 into y up to minus y at minus 1? Answer is 6. Even though solution of the differential equation is so simple, our extra burden is this y at 2 and y at minus 1, and substituting them here. There lies the answer. Another standard question appears before us. Follow the question carefully. 1 plus x square into dy by dx plus y is equal to tan inverse x. Also it has been given that y at 0 is 1. That is, this information is useful to find c, and making use of that c, we are supposed to have the value of y at x is equal to pi by 4. That is y at pi by 4 we require. Okay, right. One can easily believe that this is linear in y because x square is here, so it is not linear in x. Y is only present, so it is linear in y. Come on. Dy by dx plus 1 by 1 plus x square into y is equal to tan inverse x by 1 plus x square. Tan inverse x by 1 plus x square. This is p, of course. This is q. Absolutely linear in y. Dy by dx plus py is equal to q. Hence, the very first step, if. What is if? E power integral p dx, that is 1 by 1 plus x square dx, is just nothing but e power tan inverse x. Therefore, if, the yield of first step is e power tan inverse x. Well done. The solution is y into integrating factor is equal to integral of q into integrating factor dx. That is, y into e power tan inverse x is equal to, what is q? Tan inverse x by 1 plus x square. What is if? E power tan inverse x dx. Hence it is t e power t dt, where t is equal to tan inverse x. T e power t, and then what is dt? dt is equal to 1 by 1 plus x square dx. We recall that the derivative of tan inverse x is 1 by 1 plus x square. Hence this is e power t into t minus 1 from the fundamental results of indefinite integration, or even you can use integration by parts to have this result, plus c. Therefore, y into e power tan inverse x is equal to e power tan inverse x into tan inverse x minus 1 plus c is the solution. So getting the solution is easier. Now 2 more pieces of responsibility is laid on our shoulders. What are they? One is making use of y of 0 at 1, we are supposed to have c, and then making use of that c again, we are supposed to have y at pi by 4. So 2 things are still remained, but y at 0 is 1. That is, the curve passes through 0 and 1. That is, 1 into e power tan inverse 0 is 0 is equal to e power 0 into 0 minus 1 plus c. What is e power 0? 1. 1 into minus 1, minus 1. E power 0 is 1. 1 into 1 is 1. Minus 1 comes this side, so that c is equal to 2. What is c? 2. Okay, we could have made use of the information y at 0 is 1, which is helpful of course, for us to find the value of c. Once you have determined the value of c, and y at pi by 4 can easily be obtained by replacing x by pi by 4. That's all the procedure, and it can be done by usual simplification. You can do that. There ends the matter with that problem. The next question is ready for us. It is available on the board. If dy by dx plus 2xy by 1 plus x square is equal to 1 by 1 plus x square whole square, and y at 0 is 0, then what is y at 1? Here, we need not waste time. It is very easy to notice that it is absolutely linear in y. Y at a single place we are able to see, and x square whole square, all those things are observed here. So it is not linear in x, it is surely linear in y. And moreover, for p it is there, for q 1 by 1 plus x square whole square is there. Come on friend, what is if? The immediate first step, e power integral p dx. What is p? 2x by 1 plus x square dx. Good. F dash x by fx. What is that? E power log 1 plus x square is nothing but 1 plus x square. We are happy? This is if. Hence, the solution is, what is the solution? Y into if, that is 1 plus x square, is equal to integral of q. What is q? 1 by 1 plus x square whole square into 1 plus x square dx. How happier it is, how simple it is, how slim it is. You can cancel 1 by 1 plus x square, and 1 by 1 plus x square is just remained. What is its integral? It is nothing but tan inverse x plus c. Ultimately, the solution is y into 1 plus x square is equal to tan inverse x plus c. As in the previous problem, here also 2 pieces of responsibility is laid on our shoulders. What are they? Number 1, you are supposed to make use of the information y at 0 is 0, and then making use of that to have y at 1. Look here. But y at 0 is 0. What do you mean by that? If you put x equal to 0, you will be getting y is equal to 0. Therefore, 0 into anything, 0 plus tan inverse 0 is 0. 0 plus 1 into 0 is equal to 0 plus c. Thereby, c is equal to 0. C is equal to 0. And then, if x is equal to 1, what happens? Substitute 1 in the place of x. Y into 1 plus 1 square is equal to tan inverse 1 plus c. 1 plus 1 is 2. 2y is equal to pi by 4 plus c is 0. And hence y is equal to pi by 8. Therefore, y at 1 is pi by 8 is the answer. Is the answer. How simple it is. But the problem looks bulkier. The solution is very simple and slim. Hence the answer is y at 1 is equal to pi by 8. Let us see the next question. dy by dx plus y secant x is equal to tan x is the given equation, and the actual question is root 2 plus 1 into y of pi by 4 minus y at 0 we require. Let us see. Look at the solution first of all. Surely it is linear in V. Happily, this is P, this is Q. IF, what is the integrating factor? E power integral secant x. We know that integral of secant x is e power log mod secant x plus tan x. It's just nothing but secant x plus tan x. Therefore, IF is equal to secant x plus tan x. The first step has been completed successfully. Well done. The next step and the final step to get the solution is y into integrating factor, that is secant x plus tan x, integral of what is q? Tan x. Tan x into secant x plus tan x. Tan x into secant x tan x, its integral is secant x. Tan x into tan x, tan square x. Tan square x can be written as secant square x minus 1. Secant square x minus 1 dx. Hence, it is secant x plus tan x minus x plus c. Integral of secant square x is tan x, integral of 1 is x plus c. Ultimately, what is the solution? Y into secant x plus tan x is equal to secant x plus tan x minus x plus c. Now, two things are before, only one thing. Y at pi by 4 and y at 0 we have to find. Therefore, x is equal to pi by 4 implies, come on tell me, y into, what is secant pi by 4? Secant 45. Cos 45 is 1 by root 2 and secant 45 is root 2. So tan 45 is 1 is equal to secant 45 root 2. Tan 45 1 minus pi by 4 plus c. Therefore, root 2 plus 1 into y at pi by 4 is equal to root 2 plus 1 minus pi by 4 plus c. Call this equation 1. Again, we have to know what is y at 0. Again, x equal to 0 implies, come on, secant 0 is 1, tan 0 is 0, 1 plus 0 is 1, y into 1, secant 0 is 1, tan 0 is 0, minus x is 0, plus c. Therefore, y at 0 is equal to 1 plus c. Y at 0 is 1 plus c. Call this equation 2. Now, you subtract first equation minus second equation, what happens? Come on. That is just nothing but the requirement. Y root 2 plus 1 into y at pi by 4 minus y at 0 is equal to, you subtract this from this. 1 plus c will go away, leaving you root 2 minus pi by 4 is the answer. That is the next question for us. X dy is equal to 2y plus 2x power 4 plus x square of dx, and y at 1 is 0 has been given. With our experience, we notice that information y at 1 is 0 is given. Just need to find c, and making use of that, we have to find y at g. Let us start from this. Dy by dx is equal to 2y by x plus 2x cube plus x. How could you get this? I have brought dx this side, sent x that side. 2y by x, 2x power 4 by x, 2x cube, x square by x, x. From this, dy by dx minus 2 by x into y is equal to 2x cube plus x. Surely this is p, this is q. If is, no doubt this is linear in y. Let us start. If is equal to e power integral p dx minus 2 by x dx minus 2 into, for 1 by x it is log x, is equal to e power log x power minus 2 is equal to x power minus 2 is equal to 1 by x square. You please notice that what is if? 1 by x square. 1 by x square. Therefore, the solution is, come on, y into if, that is y into 1 by x square is equal to q into 2x cube plus x into 1 by x square dx. Come on, 2x cube by x square is 2x. X by x square is 1 by x. For 2x it is x square. For 1 by x it is log mod x or log x plus c. Therefore, the actual solution is y by x square is equal to x square plus log x plus c. As in the previous problems, here also we have two steps to adapt or two pieces of responsibility. Number one, we have to make use of y at 1 is 0, isn't it? But y at 1 is 0 means 0 by 1 square is equal to 1 square plus log 1 plus c. 0 by 1 square is 0, log 1 is 0, hence c is equal to minus 1. Okay, c has been obtained, no problem. And now we have to find y at e. X is equal to e implies, come on, what does it imply? Y by e square is equal to e square plus log e plus c. So y by e square is equal to e square plus 1. What is c? Minus 1. 1 and 1 will go away. Therefore, y is equal to e power 4. Hence, the answer, that is y at e, is equal to e power 4. That is the final answer. The next question is ready for us. If x cos x into dy by dx plus y into x sin x plus cos x is equal to 1, then xy is equal to something different in the question, the way of asking. He has not asked us the solution directly, or he has not asked at y at 1, y at 0 like that. The question looks different. xy, he is asking us. Okay, let us try. Clearly, it is not linear in x, it is linear in y. We can bring it into that form by dividing throughout the equation by x cos x, so that we have dy by dx plus x sin x plus cos x by x cos x into y, and this is possible to be obtained by dividing throughout by x cos x, by x cos x. Okay, automatically this is p and this is q. That is the integrating factor. if is equal to e power integral p. This is a huge p. Let us cut it short. X sin x by x cos x plus cos x by x cos x dx. Here x will be cancelled and here cos x will be cancelled. Sin x by cos x is nothing but tan x, and integral of tan x is log secant x. X and x will be cancelled, only 1 by x will be remained. Integral of 1 by x is log x. Log m plus log n is of course log m, and it is log of x secant x. E power log of x secant x is nothing but x secant x. This is the required integrating factor. Okay. What is the solution? Therefore, the solution is come on, y into integrating factor is x secant x is equal to integral of q into, what is q? 1 by x cos x into x secant x dx. X and x will go away. Secant x by cos x. Imagine it. What is 1 by cos x? Secant x. Secant x into secant x. Secant square x. Secant square x means integral is tan x plus c. Plus c. Therefore, y into x secant x is equal to tan x plus c. This is 1 by cos x, this is sin x by cos x. Let us multiply with cos x on both the sides. You have xy is equal to sin x plus c cos x. That's all. This is the required one. I have multiplied throughout the equation with cos x. Cos x into secant x is 1. So this is xy. And tan x into cos x is of course sin x plus c cos x. How simple it is. With no strain and pain, we are able to have the answer. Xy is equal to sin x plus c cos x is the answer. Right answer. Well, my dear, observe this equation. This is a peculiar equation. Why? Because x is not linear in this equation. At the same time, y is also not linear. How to get it solved? But we are in linear equations. We are supposed to use that. We have learnt and we are equipped with the methodology of linear equations. This is neither linear in x nor linear in y. How to get it? A very simple idea can change the life of this problem. Yes, what is that idea? Look here. Basically, we should have only x's here. Here it is cos square y. First of all, you divide the entire equation with cos square y. Let us see what happens. Let us see what happens. 1 by cos square y into dy by dx plus x into 2 sin y cos y by cos square y is equal to x cube cos square y by cos square y. We should feel happy. Cos square y goes away. Cos y. So that it is secant square y into dy by dx plus 2x into tan y is equal to x cube. And this is the right spot at which you have to get a proper idea. Now, let tan y is equal to t. Secant square y into dy by dx is therefore equal to dt by dx. Call this equation 1. 1 becomes, come on, what will be the new shape of this 1? Secant square y dy by dx is nothing but dt by dx plus 2x into t is equal to x cube. A miracle has happened. One can understand like that. You see, this bulkier equation has been brought into this simple form. This is surely linear in t, not in x or not in y. It is linear in t. Of course, this is p and this is q. Hereafter, we shall proceed in our usual way of a linear equation. Well then, what is the integrating factor? Integrating factor is equal to e power integral p dx. E power integral, what is p? 2x dx is equal to e power x square. Therefore, what do we have written? if is equal to e power x square. Integrating factor is e power x square. Then, what is the solution? Therefore, the solution is come on friend, if the given equation is linear in y, the solution is y into integrating factor is equal to. If it is linear in x, x into integrating factor is equal to. But here in this case it is linear in t, you know. Therefore, we have to start with, to get the solution, we have to start with t into integrating factor is equal to. T into integrating factor is equal to integral of q into integrating factor dx. Tan y into e power x square. What is q? What is q actually? It was x cube, it seems. As It was x cube. X cube into e power x square dx. That is equal to half into e power x square into 2x dx into x square. You observe the style of managing it. I have provided 2. I have cancelled that 2. I could have split x cube as x square into x. What is the benefit you are getting? You can write this as half into u e power u du, where u is equal to x square or du is equal to 2x dx. And we know from the fundamental properties of the indefinite integrals in the heading integration by parts, u into e power u, its integral is e power u into u minus 1 plus c. But what is u? X square. So it is half into e power x square into x square minus 1 plus c. Well done. At last we could have got the general solution only. Still it is not enough. We are to get tan y at 1. What is that? We shall see. Therefore, tan y into e power x square is equal to half into e power x square into x square minus 1 plus c. But you see, y at 0 is 0. But y at 0 is 0. Tan 0 is 0 into e power 0 square is equal to half into e power 0 into 0 minus 1 plus c. E power 0 is 1. 0 minus 1 is minus 1. Half into minus 1 is minus half. If it comes here, it becomes plus half. So that we have c is equal to half. Again, tan y is equal to half into x square minus 1 plus c into e power minus x square. From this, I have divided it entirely with e power x square. But just now we can have got c as half. This is equal to half into x square minus 1 plus half into e power minus x square. This c is tan y. But you see, we want to have tan y at x is equal to 1. Therefore, x is equal to 1 implies tan y is equal to 1 square is 1, 1 minus 1 is 0, half into 0 is 0, plus half into e power minus, you see, x is equal to 1 means 1 square is 1, e power minus 1 is equal to 1 by 2e. Therefore, tan y at 1 is 1 by 2e. That is the answer.